Find f of g of x and the domain of f composed with g, where f of x equals x squared minus 3x and g of x equals the square root of x plus 2. Well, first let's find f of g of x. By definition, f of g at x is equal to the value of f evaluated at g of x, and that is f of the square root of x plus 2. Now, the input here to f is the square root of x plus 2, and so each of these x's, where this x is the placeholder, and we should replace the placeholder with the square root of x plus 2, so we ought to have the square root of x plus 2 squared from here, minus the 3x, that in this case with this new placeholder is 3 times the square root of x plus 2, and we can simplify that a bit. The square root squared leaves just the x plus 2, and we have a minus 3 times the square root of x plus 2 here. So there's the value of f of g of x, or f composed with g. To find the domain, we need to remember that in order to produce the composition function, we'd start with an x. We first apply g to that to give us g of x, and then whatever values we get from g of x, we apply f to get f of g of x. And so there are a couple of issues that we need to worry about when we deal with the domain. First, as x is fed into g, we need to worry about domain restrictions on that evaluation. So we first need to look at places where g of x might have restrictions. Notice that g of x is the square root of x plus 2, and the square root of x plus 2 is defined only when x plus 2 is greater than or equal to 0, because the square root of a negative is not a real number. So the square root of x plus 2, or rather the x plus 2 alone, needs to be greater than or equal to 0. That gives us a restriction that x has to be greater than or equal to negative 2. That's restriction 1. We're going to have to keep that restriction in mind when we deal with the domain of the composed function f of g. Alright, so that's this restriction taken care of. Now let's look for restrictions that occur here when we apply f to the results of g of x's application. Well, f is the function x squared minus 3x, and there are no restrictions on that. That can be evaluated for any real number. So what we would need then is for g of x to be simply a real number. Well, we've already dealt with that restriction. G of x is a real number precisely when we have an x that's in the domain of g. So there's nothing new that's introduced here, and our final restriction, by combining these two sub-restrictions, here's the second of those, is that we need the domain of f of g is the set of all x such that x is greater than or equal to negative 2.